Hello and welcome to Kashmatics. In this video I'll show you how we can use partial fractions to integrate. A word of warning though, if you haven't yet studied partial fractions then please go and do that first because it's just not going to make much sense unless you do. I'll do examples of the different skills you'll need, so by the end of it I'll hopefully have covered all the different scenarios you're likely to encounter. Anyway, grab yourselves a pen and some paper and let's get started. So here's my first example, and if you're here for just a bit of revision but you want to give it a go, then please just pause the video. Otherwise, just carry on watching and I'll go through the answer. So when I'm answering a question like this, the first thing I look at is the degree or the powers of the top and the bottom. Okay, now the biggest power of x here is 1 and the biggest power of x here is 2. This is a quadratic, this is a linear. So what we've got is just a normal fraction, which means we don't need to do anything special with this other than just split it up into partial fractions. So what I have is 3x minus 1 all over 2x plus 1 multiplied by x minus 2. And I want to say that's equivalent to a over 2x plus 1 add b over x minus 2. And what I'm going to do is I'm going to write that down as a single fraction. So you multiply a by x minus 2 and b by 2x plus 1. That's all over. Now these get multiplied together. So I've got 2x plus 1 multiplied by x minus 2. Now the reason why this is useful is because if I compare this original integral to what I've got over here, I can see the denominators are the same. That means the numerators must be equivalent too. So I've got 3x minus 1 is equivalent to a multiplied by x minus 2 add b multiplied by 2x plus 1. And what I can do at this stage is I can either substitute any value of x I like, because this is equivalent to any value of x will work, or I can compare coefficients. Now in this case I'm going to put in the value x equals 2. So if I put x equals 2, I get 3 times 2 which is 6, take away 1 which is 5, and that would be equal to, now the reason I put in 2, hopefully you can see this term actually cancels out, which means over here I get 5b. Which means b is equal to 1. And what I can do then is I can either compare coefficients or I can substitute a different value of x. And I'm going to compare coefficients because the value of x which would make this bracket 0 is minus a half, and that's just a bit awkward to deal with. So I'm going to look at the coefficients of x. So the coefficient of x on the left hand side is 3, and that's equal to the coefficient of x on the right hand side is a times x, so that's a, plus 2b times x, so that's 2b. Now because I know b is 1, that would be a plus 2, which means a is equal to 1 as well. So what I can do at this stage is rewrite the thing I'm about to integrate. So rather than integrating this, I'm going to integrate this by substituting the values of a and b I've just found. So this becomes the integral of 1 over 2x plus 1 plus 1 over x minus 2 dx. And hopefully you know that when you're integrating a reciprocal function like this, it's going to be the natural log. So you've got the natural log, modulus signs, don't forget those, 2x plus 1 divided by 2, remember I need to divide by the coefficient of x, plus the natural log of x minus 2 plus c. Now at this stage you could combine the two terms and express them as a single log, but I'm not going to bother, okay? But if the question asks for it, then do it, but otherwise just leave it alone because that's where mistakes are made. Now in this second example I've got a repeated factor on the bottom, okay? So this factor here is repeated. So when I split this up into partial fractions, I'd say 17 minus 5x over 3 plus 2x 2 minus x squared is equivalent to a over 3 plus 2x add b over 2 minus x plus c over 2 minus x squared. Okay, so if you remember from when you did your partial fractions work, that's how you'd split it up. And now I'm going to write this as a single fraction. So remember, this is the common denominator, so all I do is I work out what's missing from each of these terms' denominators and put them in the numerators. So with the a, I'm missing a 2 minus x squared. With the b, I need another 2 minus x, and I need this one over here. So 2 minus x, 3 plus 2x. And with the c, I'm only missing a 3 plus 2x. And all of that is over the original denominator, which is 3 plus 2x, 2 minus x squared. So as before, I just need to compare the numerators. So 17 minus 5x is equivalent to all of this numerator over here. So a multiplied by 2 minus x squared, add b multiplied by 2 minus x, 3 plus 2x, add c multiplied by 3 plus 2x. Now the first thing I'm going to do is I'm going to say let x equal 2. Now the reason I do that is because this term disappears, so they become 0, this becomes 0, which means all of that goes, leaving me with just this term and this over here. So when x equals 2, I've got 17 take away 5 times 2, so 17 take away 10, which is 7, and that's equal to, so I can ignore these two because they become 0. 3 plus 2 2s, so 7, so that's 7c, which means c is equal to 1. What I can do now is compare the coefficients. Okay, now I'm going to choose to compare the x squared terms, so the coefficients of x squared. On this side there's no x squared, so 0 equals, now the x squared term from here becomes ax squared, so that's a, and the x squared term from here becomes minus 2bx squared, so that would be minus 2b, and there's no x squared term here. So I've got an equation here which says 2b is equal to a. Okay, I'm just going to call that equation 1. Now because this equation's got two unknowns, I need to find another equation which is going to help me. So I'm going to look at the constants, and over on the left hand side I've got 17 equals, now the constant here would be 4, so I've got 4a, so 4a, plus the constant over here would be 6, so that would be 6b, and over here it'd be 3c. And I'm just going to plug in my value of c, so I've got 17 is equal to 4a plus 6b plus 3, so I've got 14 is equal to 4a plus 6b, which means 7 is equal to 2a plus 3b. So that's equation number 2. Now I'm just going to write these two equations up here just to make the working a little bit easier. So I've got a is equal to 2b, and equation number 2 is 7 equals 2a plus 3b. Now because a equals 2b, I'm going to substitute that into here. So I'll get 7 is equal to, now 2 times a, that would be 4b plus 3b. So 7 is equal to 7b, which means b is equal to 1. And because a is equal to 2b, that means a would equal 2. So I'm in a position now where I can rewrite my integral. So just put a line down here. Okay, so my integral will become the integral between 1 and 0 of a over 3 plus 2x, so that would be 2 over 3 plus 2x, add b, which is 1, over 2 minus x, plus c, which is 1 over 2 minus x squared dx. Now I've got to be careful here. This one here, I would just use logs, and this one here as well. Now this one over here, you might be tempted to use logs, but that wouldn't be the right thing to do. What you need to do is rewrite this as 2 minus x to the power minus 2. Alright, so just be careful with this last term. So what I end up with is 2 ln 3 plus 2x divided by 2, so those 2's cancel each other out, plus the ln of 2 minus x divided by minus 1, plus 2 minus x to the power minus 1 divided by minus 1, that's the new power, but I've also got to divide by the coefficient of x, so that's another minus 1. Okay, remember these are between the limits 1 and 0. Now before I put the limits in, I'm just going to tidy things up a little bit. So this term here becomes ln of 3 plus 2x. This one here becomes minus ln of 2 minus x, and this one here becomes, this becomes a positive term, and this will just become 1 over 2 minus x, and that's between 1 and 0. So let's go ahead and plug these limits in. So the first term becomes the ln of 3 plus 2x, so that would be 5. Take away the ln of 2 minus x, so that would be ln 1, plus 1 over 2 minus 1, which is 1. So that's my first bracket. Take away, Now I've got to put the 0 in. So this would be ln of 3 take away ln 2 plus half. Okay. Now there's a few things you need to realize here. ln 1 is equal to 0. So I'll get ln 5 plus 1 take away ln 3 plus ln 2 plus 1 half, and let's tidy all of that up. Sorry, that was minus a half. Okay, and let's tidy all this up now. So let's write all the logs as a single log. So you've got ln 5 plus ln 2, which is ln 10. And because I'm taking away ln 3, I can divide by 3 to get ln 10 over 3. Then I've got 1 take away a half, which is a half. So that's your final answer. So there's a lot of places where you can trip up here. Okay, and the main thing is this term over here. When you come to integrating that term, you've got to rewrite it as a power of minus 2, because otherwise you're going to end up maybe using a log, and that's the wrong thing to do. Remember, logs can only be used when the denominator is to the power 1, and here the denominator was to the power 2. So in this example, I've got an improper fraction. Now what makes it improper is the fact that the top is cubic and the bottom is quadratic. So the degree of the top is 1 bigger than the degree of the bottom. Even if the degrees were equal, it would still be an improper fraction. So when you've got a situation like this, the first thing you need to do is divide it out. So I need to divide x cubed plus 2x squared plus 0x plus 2. Now I always put down all the components of the polynomial, even if the coefficient is 0, divided by x squared plus x. That's just this expanded out. So I need to look for how many x squareds go into x cubed, or what do I multiply x squared by to make x cubed, and the answer is x. Then I multiply x by this term over here, well both these terms here, and I get x cubed plus x squared. And then what I do is subtract what I've got so far. So these two make 0 and these two make x squared. Then I bring down my x's, okay, which in this case is 0x. So how many x squareds make x squared? It's just one of them. Then I multiply 1 by each of these. So that would be x squared plus x. Subtract to give me minus x plus 2. Now I'd stop there because there's nothing else left now. I can't multiply x squared by anything to make this term over here. Alright, so I can stop, which means this can be written as x plus 1 add, and I'm just going to write this the other way around, 2 minus x over x brackets x plus 1. Okay, so that's the first stage in splitting up into partial fractions. So this is the bit, it's a bit like saying, 3.5, that's your 3 and that's your half. It's a bit like a mixed number. And what I'm going to do is split this bit into partial fractions. Now if you've got no idea what I've just done there, then I've got a video on polynomial division which you can go and watch, and then you can come back and do this again. Anyway, let's split this bit up here. So what I want is 2 minus x over x brackets x plus 1 to be equivalent to a over x plus b over x plus 1. I'm just going to write this as a single fraction, so that's the same as a x plus 1 add bx all over x brackets x plus 1. All I need to do now is compare the numerators. So I've got 2 minus x is equivalent to a x plus 1 add bx, and I can choose values of x to substitute, and I'm going to choose minus 1 to get rid of this term. So if I say let x equal minus 1, so I get 2 take away minus 1, which is 3, and that's equal to b times minus 1, which is minus b, okay, which means b is minus 3. And then I can look at my constants, and I get 2 is equal to a times 1, which is a. So nice and easy. So what I can do is I can rewrite my integral now. So the integral becomes integral of x plus 1 add this, which is the same as all of this, which is 2 over x take away 3 over x plus 1 dx. Right, and we're almost there now, so let's just integrate this. So I've got x, which becomes x squared over 2 plus x plus 2 ln x take away 3 ln x plus 1 add c, and I can just tidy things up a little bit. So this is still x squared over 2 plus x. This becomes ln of x squared take away ln of x plus 1 cubed add c, and then I'm just going to combine these logs to get x squared over 2 plus x, add ln, oops, let's tidy that up a little bit, ln of x squared over x plus 1 cubed, add c. Oh, and these are actually modular signs, not brackets. In this last example, I've got another improper fraction, and I'm going to deal with this one slightly differently. Now, in this one, the degree of the top is the same as the degree of the bottom, and when that happens, you have a constant at the beginning, so in this case a, plus then the rest of it gets split up as you normally would. So b over 4x plus 1, add c over 4x minus 1. Now, if the degree of the top was 1 bigger than the bottom, so like we had before, we had a cubic over a quadratic. If it's 1 bigger, you add a linear term at the start, so ax plus b. If it's 2 bigger, you start with a quadratic term and then split the rest up as normal. If it's 3 bigger, you end up with a cubic term and then write down the rest as normal. So let's go ahead and write this as a single fraction. So that would be equivalent to a multiplied by 4x plus 1, 4x minus 1, add b multiplied by 4x minus 1, add c multiplied by 4x plus 1, all over 4x plus 1, 4x minus 1. And what we can do now is compare numerators and then work out what a and b are. So we've got 32x squared, add 4 is equivalent to a multiplied by 4x plus 1, 4x minus 1, add b multiplied by 4x minus 1, add c multiplied by 4x plus 1. And the first thing we do is look at the coefficients of x squared. So we'll look at the x squared coefficients. So over here I've got 32, and that will be equal to, over here I'll end up with 16x squared multiplied by a, so that would be 16a, which means a is equal to 2. And then I'm going to look at my coefficients of x. So coefficients of x, on the left hand side I've got nothing, equals, now over here the coefficients of x actually cancel each other out because that becomes a minus 4x and a plus 4x, so they'll cancel each other out, so nothing from there. Over here I've got 4b, plus over here I've got 4c, okay, which means 0 is equal to b plus c. Let's call that equation 1. And then I'm going to look at my constants. Over here I've got 4 equals, now over here I'm going to end up with minus 1a, so minus a, plus over here I'm going to end up with a minus b, so sorry, that would be a minus b, add over here I've got c. Okay, now because I know what a is 2, okay, so 4 is equal to minus 2 minus b plus c, which means 6 is equal to minus b plus c, and that is equation 2. Now if I add together equations 1 and 2, so 0 plus 6 is 6, the b's cancel out to give me 2c, which means c is equal to 3, and then what I can do is I can just work out what b is. Because b plus c is 0, if c is 3, that means b is minus 3. So we're in a position now where we can rewrite our integral, so let's just do that. Okay, give ourselves a bit of room. Right, okay, so the integral becomes the integral between 2 and 1 of a, which is 2, plus b over 4x plus 1, so that would be minus 3 over 4x plus 1, add c, which is 3 over 4x minus 1 dx. Let's go ahead and integrate all of that. So 2 becomes 2x, take away 3 ln of 4x plus 1 over 4, plus 3 ln 4x minus 1 over 4, and that is between 2 and 1. So let's plug the numbers in. That equals 2x, so that would be 4, take away 3/4 ln, now 4x plus 1, that would be 9. Okay, so if x was 2, that becomes 9. Add 3/4 ln, this becomes 7, So that's the first bracket sorted. Take away, now I'm going to put 1 in there now. So 2 times 1 is 2. Take away 3/4 ln. This would be 4 times 1 plus 1, so that'd be 5. Plus 3/4 ln. So this would be 4 times 1, take away 1 is 3. Okay, now we just need to tidy all of that up. So I've got 4, take away 2, which is 2. Plus, and I'm going to factorize out the 3/4 here. Okay, so I've got ln 7, these are my positive ones first. Take away ln 9. Now this will become a positive term because minus and a minus, so it'll be ln 5. And this will be a negative one, so take away ln 3. And let's just simplify all of that. So I get 2 plus 3/4 ln. Now the positive ones I need to multiply, so 7 times 5 is 35 over, now I need to multiply the negative one, so 9 times 3 is 27. And that's it. I can't simplify it any more than that. And that's all I've got to show you as far as integration using partial fractions is concerned. Next time we'll be looking at the trapezium rule, which is a way of approximating areas under a graph for functions you can't actually integrate. But for now, thank you for listening and thank you for watching. Goodbye.